Okay, this is lesson 17 for 7th grade, and today we did a quick lesson on measuring angles. This is definitely a review. It's where we use protractors to measure angle degree measures, and I don't have protractors for everybody. I have quite a few of them, but we didn't use them today. We will in the future, and I will get some more. But today we just kind of went over the basics and just covered everything together, which you'll see on the board here, and then went through our assignment. So, measuring angles. First thing we need to know, angles are commonly measured in units called degrees. Okay. The abbreviation for degrees is a small circle written above and to the right of the number. So that right there might be kind of hard to see. But one full rotation, that would be around this point here, is 360 degrees. I told the kids to think about snowboarding, that type of stuff, where, you know, if you do a full rotation, it's a 360, and it gets as crazy as 720s, 1080s, that type of thing. So one full rotation is 360 degrees. That means half of a rotation must be 180 degrees, or the same thing as a straight line, which we can see right here, 180 degrees. And a right angle measure is 90 degrees. That's where we have a square corner, basically half of this. So we went from full circle to half circle to quarter circle. So 360, 180, and 90. And those angle measures are important because those are the ones we use to define the names of other ones. So an acute angle, and I know we've gone over this before, is greater than 0 degrees but less than 90 degrees. So they're the small ones. Right angle, exactly 90 degrees. Those are going to be very important in the future. For geometry, trigonometry, that type of thing. Obtuse, greater than 90 but less than 180. And a straight angle, exactly 180 degrees. That's our straight line. And as I mentioned before, a protractor can be used to measure angles. So when we look at some examples coming up here, we're going to use a protractor. It looks like this here. This is what we could use to measure some angles. In the future, and I will say this, how do I want to word it? Well, in the book, in the future, we're going to be doing some problems where we have degree measures, and we will not be using protractors to find those angle measures. It might say, find the missing angle measure, and it'll give us a certain amount of degrees that are already in this shape. Don't be deceived or tricked by what the book is showing you. You're going to want to mathematically figure out what those degree measures are, but it might not look like the actual angle measure. That's okay. Also, don't assume you have a 90-degree angle unless told that it is 90 degrees, or if they tell you you're working with a square or a rectangle, that type of thing. That's just kind of a foreshadow for the future, and don't worry, I will highlight those points again once we get there. But for now, if we look at this angle right here, oops. That would be angle AOB. Now we've got two options here, it looks like. 30 degrees or 150 degrees. Well, here's how we know which one it is. This angle right here that I highlighted, AOB, is an acute angle, and we know that acute angles are less than 90 degrees. So that automatically eliminates 150 degrees right there. That's gone. So we know that that angle measure is 30 degrees. Also, the other way to know that, if we weren't sure, we look at where the angle starts. It'll start on this line somewhere, and it starts here at 0. Make sure you're counting up. So 0, 10, 20, 30. That's the other way we can do that. So for angle AOC, we have 70 or 110. Well, that's going to be, we always start at 0 here. That's going to be an obtuse angle, so that has to be 110. And also we start over here at 0, so, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. So that's how we would go above that. So then if we did AOD, we'd be at 150, not 30 degrees there. Yeah. And we'll look at an example here quick with a blown up protractor. It says find the measure of each angle here. Alright, so first one we want to find is angle AOB. That would be AOB. So we're looking at this right here. AOB. Alright, so we started over here 0, 10, 20, 30, 40. And it's between 40 and 50, and it looks like it's exactly halfway between 40 and 50. We could count up these lines here, 41, 42, 43, 44, 45. So we are at 45 degrees right there. AOD, that one's going to go from AO to D. This is an obtuse. And that goes through 140 and 40, but we can see it's an obtuse angle that is 140 degrees. And EOD. Now this one starts from this side, EOD. So that's this one right here. So if we erase our other two lines here, get rid of this so we can see it a little better. So EOD, now we're starting from this side, so we're going up 10, 20, 30, 40. So this would be 40 degrees. Alright? That's how we go about using the protractor to find them. We would have to make sure that we're lined up on our 0 line there and go from there. Alright. And one last thing we need to take a look at. Use a protractor to draw a 60-degree angle. I didn't have the students do this today, they will in the future, but if we look at a protractor here, they would line up on a straight, and from there they would extend a line up to our 60-degree mark. That's where this dot is here, and we would draw up like that. Mine's a little off, but that would be a 60-degree angle right there. Alright, basically everything extends from this center point on the straight line. Okay, that was mainly what we covered today, some review with protractors and measuring angles. And a lot of this stuff in the future is going to be pretty big for them. And I should have the homework out on the homework link by tonight. I'll try to put that up right now. And we will continue with lesson 18.